Okay, this is the last video we have showing you how to reduce ARCoIRIS data. In this video, I'm going to show you how to do the Telluric correction on your spectra. So, in the last step, we combined together our extracted spectra for both our Telluric standard as well as our science target. So what we're going to do is, in IDL, we're going to type in xtellcor. Okay, so the first thing we want to do is put our standard spectrum in there. And what we want to have here is the B and V magnitude for our standard spectrum. Now, I should mention here that the telluric standard that you're using needs to be an A0 or very close to an A0 star for this to work. And as a part of determining the A0 that you use, you should also find the B and V magnitude and put those in. So I've done that. I know that this is B of 9.72 and V of 9.7. And now I want to put in the object spectrum, and we can load those up. So a couple of things here. You can see it gives you information about the air mass for your standard and the air mass for your object and the difference. If the air mass difference is greater than 0.1, this will wind up being red because that's bad. So you should try and make sure when you're doing your telluric standard observations that you're getting them as close in air mass as possible. I should also mention that ARCoIRIS sometimes gets a bug where the TCS doesn't talk to the instrument the way it should, and so what winds up happening is sometimes those frames will wind up having air masses of 0. So then it might be a good idea to check your logs and make sure that everything is a good air mass match. Okay, so we have those in, they're loaded. The next part that we're going to do is construct a convolution kernel. So essentially for this part, what we're going to be doing is trying to come up with a way to remove, I guess, the hydrogen lines that are in the A0 star. So this was why in the second video I recommended that for telluric standards you always have order 6 extracted, because the easiest line to do this with is in order 6. So we'll go ahead and select order 6 and construct our kernel. The line we're going to use is this one right at around 1 micron. And to go through and set up our kernel, so the kernel is going to determine the rotation speed, it determines the radial velocity, how much it needs to shift the spectrum by, all of that stuff. So it does a lot of things to remove the hydrogen line in this particular order and fit it. And then it applies that to lines in other orders. So what we're going to do is I'm going to zoom in on this line. To zoom, you hit Z and then click around the box that you want to use. Now what we need to do is fit the continuum here. And so to do that, we hit N, and we're going to click on areas that do not have contamination from telluric lines. And the telluric lines are shown as these yellow things that you see up on top, so there's not much telluric lines here. And we don't want it to include any part of that hydrogen line. So I set those up as our continuum, and we find that actually the fits here, you want to have a fairly high fit degree, that it actually does pretty well if you have a fit degree of 7 or 8 or 9. Okay, so you want to make sure your fit looks pretty good and that it looks like it's providing kind of a reasonable baseline underneath the hydrogen feature. So once we have that, we're going to head and click normalized. And now there is our hydrogen line. Okay, so to fit it and construct the kernel, what we're going to do is we're going to select the region that contains the hydrogen line. So I'll do S, and I will click on either side of that line, and now I can hit construct kernel. And you can see down here, it shows you your data in white, and then it shows the fit that it winds up getting. And the blue here is what you really want to look at, these residuals, and make sure that there's nothing here that looks really, really terrible. In general, if you have a RMS deviation that's below 1%, you're in pretty good shape. So this looks great. If I wanted to change it, all that I would do is go up here and hit S again and click on either side of the line so you could change. I could try fitting this huge window if I wanted to. but that's not going to work. Well, it actually did pretty good. So you can kind of play around with that to figure out what gives you the best looking residuals. So let's go back to what I had before. Something like that. Okay, so I'm going to go ahead and accept that. So, so that created the kernel, and it applies that kernel to every order, but you know, not all A0 stars are identical, so it means that you oftentimes have to tweak some of the lines, that some of the hydrogen lines might not have been optimally removed. And to do that, what we're going to do is hit this Scale Lines button. Now, one thing to note is as we go through this, don't hit this Accept button until you've gone through every order. Okay, so what we have here is in white is our A0 standard spectrum, and in yellow is a Telluric spectrum that's just, you know, from a library that we have. And it labels where the hydrogen lines are, and you want to make sure that these have been you know, removed as well as you can. So in this case, I'll do Z, and I'll zoom in here on the bracket gamma line. Okay, and you can see that the bracket gamma line was removed pretty well. It looks like maybe I could take a little more out. And to take a little more out, you can move this green dot, click it and drag it up and down, and that will wind up moving and changing the depth of the line that you're removing. Okay, so W again gets you to the full spectrum. So let's go to order 4. Order 4, you almost always need to make corrections because these bracket lines in the H band usually aren't the greatest fit. So we're going to zoom in, that's a Z, and I will click on the areas with these lines. Okay, so you can see that there's some residuals here that we'll need to remove. So to remove these residuals, you can do what we did in order 3, which is you can move these things up and down, the green dots here, until you get something where the line looks like it's removed. That works fine. Another thing that you can do is say that I want to remove this one, I can have it estimate what that correction should be. To do that, I click E, and I click on either side of the residual I want removed. And then it estimates how to basically drag that green dot down. So you can go through all of the various lines and get rid of them. And once you have something that you're pretty happy with, you know, that looks pretty good. We'll look at the whole spectrum again. 4, again, that's one where you oftentimes have to make corrections. And then you move on to the next order. So let's take a look at the residuals for this Passion Beta. That's Z to zoom in. Okay, we have a Telluric feature there. Okay, so this is an example maybe where this line is not being taken care of very well, and it might not be able to be fixed by just dragging it up or down. Yeah, see, it kind of has some weird structure to the line. Kind of strange there. So this leads to another way that you can remove these residuals from your spectrum, and that is you can just basically mask them out, sort of. So to do that, I find the area that I want to mask out, and I hit F, and I click on one side and then the other, and it draws a line correcting them. So when all else fails, you can always do that. It's also nice to sometimes do that, like if you see that there's something in the spectrum that maybe was a bad pixel, you can actually also remove it in this step. So like, you know, maybe this here was something bad and isn't actually a Telluric feature. So if you think that's the case, you can do F and then just click, and now I got rid of that. Okay, so that was order 5. Let's look at the whole order again. That looks good. Let's look at order 6. 6 is where we did the fit, so you usually, constructed the kernel rather, so you usually don't need to make a correction here. And 7 and 8, you usually do need to make some corrections. So we will zoom in here, and we'll do E, remove all these lines, and if there are even some residuals, you can even go back and do it again. Okay, and again, let's W to see the whole spectrum again, the whole order. If we're happy with that, that looks good, and then we can move on to the last order. So once we've done this for all the orders, our next step is going to be constructing the actual telluric spectrum. So right, what we're doing here is we're correcting the A0, which is different from actually turning it into a telluric spectrum. So, okay, this looks pretty good. All right, I'm happy with that. So I've gone through all the orders, so I can click accept. Next step, I can hit this construct telluric spectra. And it tells you up here what the units are going to be. So if you wanted to change it to something else, you can knock yourself out. Okay, the next step that we're going to do is sometimes there are wavelength shifts between our telluric spectrum and our science spectrum. Now I will say that in my experience with ARCoIRIS, these are usually very small. Because the instrument, all of the optics are fixed, it means that in general there's very little shift between your telluric and your standard. But let's go ahead and we'll take a look. So we only have one aperture to choose from, so aperture 1 it is. Order 3 we're going to start with. So we do that, click Get Shift, and what we're going to want to do is pick a region that has decent signal to noise but still has a number of telluric lines. And having your mouse in this upper panel, you want to hit S and click on either side of the region where you want to do the cross correlation. And it actually does an auto find, and it will find the best shift. So again, you can see that we have a shift here that's subpixel, which is really standard. So what you're going to do now is you go through all of the different orders and you would also get the same shift. In this particular case, I'm just going to go ahead and use the 0.61 in order 3, and the rest of them will just be set as 0. Okay, and let's do my output name here will be science_xtc. I like to use the xtc to denote that this has been xtelluric corrected. And then you can also have it put out the telluric. This is very useful if you have science targets that are going to be using the same telluric. So 2 science targets, same telluric. You can put this out and then you actually don't need to go through this whole step again. You can use a program called xtellcor finish. You can also have it put out the model. All right, so once I'm there, I can write my file, and now I have my reduced spectrum. And one of the nice ways to look at it using this XVspec is I can hit this continuous button, and it actually will go through and it stitches together all of the orders. Well, it doesn't stitch them together, it just overplots all of them. And so it's a nice way to look at the entire spectrum. So it looks really, really great. And that is basically the last step that you have in your reduction of ARCoIRIS data. If you want to combine your orders together, some people want that stitching to be done so that they just have a single spectrum instead of different orders. You can use a program that's called xmergeorders. And we can load in our science XTC spectrum here. And this is pretty self-explanatory. You wind up just going through, selecting the orders, and then you can merge them as you go. So you add each one, and you merge them. So pretty straightforward and easy to use. And again, all of these have help files that can help you if you're wanting to do that. Okay, so that's how you go through a reduction of ARCoIRIS data. I hope you found this useful, and I certainly would appreciate if you are using the ARCoIRIS package and you find it useful, that you give me a little shout out in the acknowledgements of your paper. So a nice thank you to Katelyn would be very appreciated. All right, thanks for listening and happy observing.